So, ladies and gentlemen, I hope you had an enjoyable lunch, and I see I need to go a little to the side because otherwise the projector is really blinding me. I see there's quite some people already here. Maybe some more will find their way here, and I'm very happy and proud to be able to present the session Digital Technology Solving Problems. And we will have a very compact program today. So again, for all the speakers, please keep your timelines in the interest of the audience. And now I would like to start to give you a little introductory. So I thought quite some time, what is digital technologies and what is solving problems? And that led me to the question, so what is required for digital technologies to solve problems? And let's start with some digital technologies. So I will try to paint a very simple picture. So if we talk digital, then we have a lot of technologies, especially in the utility space. There's a lot of technologies out there in the field, like smart meters and power quality sensors and breakers and reclosers, all the things you name it. And the one thing that in terms of digital is they are all kind of measuring things and make them digital and then send them to some kind of controller that then is using this information to do something. So basically what this does, it is converting aspects of the real world into something that's represented in the digital world. And it's primarily doing it for its own purpose. So as I said, a smart meter is actually doing this. And the interesting thing starts if we start to give this device or this piece of equipment an API, an interface, so that other things can get access to the data inside of it. And the moment we do that, this data is leaving. So kind of a smart meter is, in the first place, is a silo. It's measuring things and has it inside and does something with it. And then if it's in its own silo, or take a protection device, it's measuring a lot of things and keeping it to itself, using some algorithms on it, and then doing something with it. But if we now start to create an API and take that data out, and put it in context with other measurements and other aspects of our system that we can measure, then we are creating something like a digital repository where all these little measurements come together. And this is where, for example, you can create a dashboard where you're taking information from, for example, several meters or from several protection devices, reclosers, and put them into context and look at them. This is the primary, so in the intersection, I think I can use a pointer here even, in the intersection of these two, we're talking about things like dashboards and so on. So the first form of digital solutions, solving some problems, but maybe not too many. And now the third thing that's really interesting is how do we represent the system itself in the digital space? So what does it mean if a power quality sensor is measuring something somewhere, and what does it mean to the system? And what is happening if it stays like that? So example, we see an overload. We see, for example, a transformer, we are measuring the temperature, and the temperature is going beyond a certain threshold. Then in the end, we need some kind of domain intelligence to put some context to it. So is this a good thing? Is it a bad thing? So do we want the oil to be hot? Do we want the oil to be cool? Or what are we doing with it? And in that regard, this is, I think, one of the more challenging aspects of this. We need to represent this in the digital space. And we do this, for example, again in silos. If I take the digital protection again, then we're using the instrumentation and put the domain intelligence together with it in one box. And this thing now protects the line, but it's in the overlap of these two. So the interesting thing is, what is it if we put them all into one spot? So if we all bring them to overlap. So we have an instrumentation, we're measuring aspects of a system. We are putting them all together in a digital repository, and we're using the domain intelligence to really understand what all of this means to the system that we're looking at, for example, to our grid. And this is where the technology like IoT kicks in, and this in the end is, I think, the pathway where we are really talking about digital technologies solving problems. And ultimately, to really enable that is, I think, in this industry, we need to understand how can we move the things that we have always done, so it's a brownfield, we have always done these things, how do we bring them together properly to really enable the potential that lies in these technologies, and especially beyond its local application? Because in the digital space, we are not limited by space and time. So if I have a measurement like the oil temperature digitalized, I can look at it, be very far away and look at it, and I can also look back in time, and I can project forward in time. And that's something that I can't do in the real world. In the real world, I can go there, I can look at a dial, and I can only see what's happening in that instant. And if I blink my eyes, what's happening in that time period is lost and has never been recorded. So basically, IoT is really extending the scope of the solutions, and therefore also the scope of the problems that we can solve. And from that perspective, I'm very happy that we have so many speakers today in the session that will shed some light on this, all from a different angle. And in that regard, I would like to invite to the stage, in the first place, Fabrizio Mandolesi, sorry for that. He's the head of billing and customer value management in Acea Energia in Italy. Together, he will do this presentation together with Franck Chevalier, who is the head of the global market energy and utilities and the CEO of Atos Worldgrid. Please welcome with me to the stage Franck and Fabrizio.